The CEHF Blended Learning Course, Health-Related Physical Fitness Assessment and Programme Design. This is lesson 9 and we're going to look at the treadmill jogging test and the Astrand treadmill test. The aim of the lesson is to introduce the students to the procedures used when administering the treadmill jogging test and the Astrand treadmill test when assessing cardiorespiratory endurance. The learning outcomes: you will learn the procedures used when administering the 2 treadmill tests on a client. You will be able to determine client suitability when administering the tests. You will be able to distinguish between the advantages and limitations of the 2 tests, and also to establish VO2 max from the results. So the first one we're going to look at is the treadmill jogging test. The component of fitness, as we said, is cardiorespiratory endurance. That's what we're testing. And the indicator of that is VO2 max. So we're trying to find VO2 max again. Client suitability. This test is suitable for the fit client who is used to running on a treadmill. This test has been validated as a predictor of VO2 max when 2 steady state heart rates are achieved between 110 and 150 beats per minute. And that is important. We need to keep that in our head when we're doing the test. We need 2 heart rates to stay in between 110 and 150 beats per minute for the test to be valid. If the heart rate goes over 150 beats per minute, the test should be stopped. The equipment needed: a treadmill, a stopwatch, the heart rate monitor and a recording sheet. The test procedures then. Well, first of all, before you put the client on the treadmill, record the client's age, their weight in kilograms, their resting heart rate, predicted maximum heart rate and 85% of maximum heart rate. Going back to one of the earlier lessons, we will remember how to get maximum heart rate. We subtract the age from 220 and we learned how to get 85%. So we're going to subtract the client's age from 220 and multiply by 0.85 to get 85% of the maximum heart rate. And the reason we're getting 85% of maximum heart rate is that we're going to monitor the client's heart rate throughout, and we're not going to allow the client to go over 85% of their maximum heart rate. If they do, we're going to stop the test. Warm up the client for 2 minutes at 6.4 kilometers per hour. Then we can start the test. So stage 1, we're going to set the workload at 8 kilometers per hour and we're going to run for 2 minutes. Take the heart rate after 2 minutes. Run for another minute and take the heart rate again. And look for steady state. We discussed steady state in an earlier lesson, and if you remember, it is oxygen supply equals demand. And how we know we have steady state is if the 2 heart rates are within 5 beats of each other. So if the heart rate after minute 2 and the heart rate after minute 3 are within 5 beats of each other, we have steady state and we can move on to stage 2. If steady state is achieved, move on to stage 2 as I said, but if not, run for another minute to try and achieve steady state. So go for minute 4 and try and achieve steady state. If steady state is not achieved at all, you must stop the test. So if unable to achieve steady state, the test should be stopped. If steady state is achieved, we'll move on to stage 2. So we're going to set the second workload at 9.6 kilometers per hour, upping the speed there from 8 kilometers an hour where it was at the first workload. Record the heart rate again at the end of 2 minutes. Run at the same speed for another minute and take the heart rate again as we did in stage 1. Look for steady state again between the heart rate after minute 2 and minute 3. And if steady state is not achieved, run for another minute and see if you can get it then. If unable to achieve steady state, stop the test. If steady state has been achieved, then record and the test is complete. But the 2 steady state heart rates must be between 110 and 150 beats per minute for the test to be valid. Cool down the client. Advantages and limitations of the test. Well, the advantages first: heart rate is monitored throughout the test. The test is run under controlled conditions. And the limitations: it's not suitable for group testing. Pulse rate must stay between 110 and 150 beats per minute. This can be problematic for some subjects, and the result needs quite a bit of calculation. Okay, so we're going to look at the speeds now that we would begin the treadmill jogging test, right? So the speeds we used in our example there, we used stage 1 and stage 2. We were running at 8 kilometers an hour, and stage 2 was 9.6 kilometers an hour. Why are there 7 stages? Well, sometimes a client might not get the heart rate up to 110 beats per minute. If the client is very, very fit with a very low resting heart rate, we might need stage 3, 4 and so on. So we might even start some clients off at stage 2 and then we progress on to stage 3. So that's why there are 7 stages. The important thing here to remember is stage 1, 8 kilometers an hour, 5 miles, whichever, it doesn't matter which you use, 8 kilometers an hour for 2 minutes. And the workload then is expressed as 30.1 milliliters per kilogram per minute of exercise. This would be the general oxygen uptake while working out at that level, 8 kilometers per hour. So if we look over here at the formula, then VO2 max equals SM2 plus B, heart rate max minus heart rate 2 in brackets. Right, so you're going to ask, well, what do all these numbers and letters mean? Well, the first one is, we look at SM1. SM1 is submaximal workload 1. So we started off at stage 1, which was 8 kilometers per hour, and therefore the submaximal workload 1 is 30.1. We went on then to stage 2, which is submaximal workload 2, and we went on to 9.6 kilometers an hour for 2 minutes and 3 minutes, and that is 35.7. So SM1 is 30.1, SM2 is 35.7. If we had to go on to stage 3, well then SM2 would have been 40.9 and so on. Heart rate 1 is the heart rate recorded at the 3rd minute of stage 1, and heart rate 2 is the heart rate recorded at the 3rd minute of stage 2, or whatever the last minute was. If you had to go on to minute 4 to achieve steady state, well then heart rate 2 would be that heart rate that you got at minute 4. It's whatever one you got last. Okay, so we'll have to talk about this chart again. Right, so we're going to look at an example. Mary is 28 years old and did the treadmill jogging test, and her results are as follows. So we started her off at 8 kilometers an hour, and after we took her heart rate after 2 minutes, and it was 125. So you can see it's over 110 and under 150, so it's useful. We took the heart rate again after minute 3, and it was 130. We have steady state. They are within 5 beats of each other. If we didn't get steady state here, I would keep her going for another minute. So I would take the heart rate after minute 4. Moving on to stage 2 then, we moved her up to 9.6 kilometers an hour. We took the heart rate after 2 minutes, it was 136, and we took it after another minute, and it was 140. Again, we have steady state here, and all of the heart rates are between 110 and 150 beats per minute. So what we need to do then is to put those into the formula, and the first thing we're going to do is we're going to calculate B. What B is the relationship between the workload on the treadmill and the heart rate of the individual. So if we remember back to our chart that we looked at in the previous slide, SM2 minus SM1, submaximal workload 2 minus submaximal workload 1, we read those off the chart, which is 35.7 minus 30.1. Heart rate 2 was the last heart rate we got at stage 2, which was 140, minus heart rate 1, which was the last heart rate we got at stage 1, which was 130. So if we calculate that out, then 5.6 over 10 equals 0.56. So now we have B, which is the relationship between the workload and the heart rate of the individual. Now we can go on and calculate VO2 max from that. Okay, so VO2 max, again looking at the formula, is SM2, submaximal workload 2, plus B, which we've just calculated. Heart rate max is 220 minus the person's age, minus heart rate 2, which was the last heart rate we got at stage 2. So if we put all that into the formula then, submaximal workload 2, we read it off the chart, it's 35.7, plus 0.56, which is B, we've just worked it out. Heart rate max is 220 minus Mary's age, which was, her age was 28, so that's 192, and 140 was heart rate 2, which was the last heart rate we got at stage 2. So if we calculate that out, then, as we've said before, once you see brackets, you do what is inside the brackets first. So the first thing we do is 192 minus 140, and that gives us 52. What's outside the brackets then, we must multiply 52 by 0.56. 52 multiplied by 0.56 is 29.12, and the last thing we have to do is add on 35.7, which gives us our answer at 65 milliliters per kilogram per minute of exercise. That is Mary's VO2 max, and we need to go to check our standards then and find out whether her cardiorespiratory endurance, whether this VO2 max for her age is good, average, above average, excellent, or whatever, and provide feedback. Okay, so we're going to give you a task now to see can you do that on your own. Right, so John is 30 years old. He did the treadmill jogging test and his results are as follows. Stage 1 at 8 kilometers an hour, his heart rate after 2 minutes was 138, and his heart rate after another minute, 3 minutes, was 141. We have steady state here, so we're going to go on to stage 2, 9.6 kilometers an hour. Heart rate after 2 minutes was 145, and after minute 3 was 148. We have steady state all the way, and we have all the heart rates between 110 and 150 beats per minute. So we're going to use the formula to calculate John's VO2 max, and the first thing you're going to do is calculate B, which is the relationship between the workload and the heart rate. So I want you to pause the presentation for a few minutes, go back through the slides again if you must, look at the manual and have a go at that calculation and see can you do it. Okay, so coming back, we're going to use the formula to calculate John's VO2 max. First, we'll calculate B. Right, so submaximal workload 2 minus submaximal workload 1. We read off the chart, 35.7 minus 30.1 gives us 5.6 again. Heart rate 2 minus heart rate 1, which was heart rate 2 is the last heart rate he got at workload 2, and heart rate 1 was the last heart rate he got at workload 1, which gives us 7. So if we calculate that out, we get 0.8. Now we've calculated B. The next thing we have to do is find VO2 max. So VO2 max again, submaximal workload 2 plus B, heart rate max minus heart rate 2 in brackets. Again, put all the information again into the formula and write it out again. So submaximal workload 2 is 35.7. We read that off the chart, plus 0.8. We've just worked out B. Heart rate max is his 220 minus the age, so 220 minus 30 is 190, minus 148, which was heart rate 2, which was the last heart rate he got at workload 2. So the first thing we do is do what is inside the brackets first. 190 minus 148 equals 42. The second thing we do is get rid of the brackets by multiplying 42 by 0.8, which is 33.6, and finally add on 35.7, which will give us our answer 69 milliliters per kilogram per minute of exercise. That's John's VO2 max. Go to the standards, check out whether it is good, average, excellent, whatever, and give feedback to John. Okay, so that's the treadmill jogging test. We're going to move on now to the Astrand treadmill test, which is another running test. The component of fitness again is cardiorespiratory endurance, and the indicator is VO2 max. Client suitability. This test is suitable for fit or very fit individuals who are used to running on a treadmill. The equipment needed: a treadmill, a stopwatch, a heart rate monitor, and the recording sheet. The test procedures. Well, we're going to warm up for 10 minutes. We're going to set the first workload at 8 kilometers an hour at 0% incline. And the client is going to run at that workload for 3 minutes. So the stopwatch is on at this stage. Increase the incline by 2.5%, and the client continues to run for another 2 minutes. Increase the incline by another 2.5%, and the client runs for another 2 minutes. Every 2 minutes, increase the incline by 2.5%. And the test is complete when the client is no longer able to continue. Record the time at which the client stopped. The advantages and limitations of this test. Well, first of all, the advantages. The test is fairly maximal, so it is generally more accurate than other tests. The conditions are controlled, and it is very time efficient. The limitations of the test is not suitable for group testing, and the result needs a little bit of calculation. And it is only suitable for the fit or the very fit client. Calculation then, not too bad. This time, VO2 max equals the time multiplied by 1.444 in brackets plus 14.99. And again, as usual, we will do whatever is in the brackets first. So, for example, John did the test and stopped after 13 minutes and 15 seconds of running. That's 13.25 minutes. Okay, so that's John's time. So we put that into the formula then. 13.25 multiplied by 1.444 plus 14.99 at the end. If we multiply out what's in the brackets first, we get 19.13. Add on 14.99 and we get 34 millilitres per kilogram per minute of exercise is John's VO2 max. Again, check the standards to assess whether his cardiorespiratory endurance is good, average, above average, excellent, or whatever, and give feedback to the client. Task. We'll come back to Mary. She did the treadmill test and she stopped after 12 minutes and 30 seconds of running. So again, use the formula in the previous slide to estimate Mary's VO2 max and pause the presentation and come back to it to check your answer. So we're going to calculate using the formula again. 12 minutes and 30 seconds, that's 12.5 minutes, so 12.5 multiplied by 1.444 first gives us 18.05, and the last thing we do is add on 14.99. The answer is 33 millilitres per kilogram per minute of exercise. That's Mary's VO2 max, and again check the standards and give feedback to Mary. In the next lesson we're going to look at the treadmill walking test.